All right, we have a fun one. Here we go. You're looking at this and saying, what is this little triangle times x? Okay, first of all, this is the Greek letter delta, which is a triangle, and it is not delta times x, it's actually delta x. Delta represents change. So what we are looking at is, you don't have to write this, but it's fun. This is the change. I don't know where I was going with trying to write the change and putting that. Thank you for writing it. The change in x. Okay, so here's what we really have. I hope you noticed that we have x plus delta x. So I basically have some x value plus the change. So it's x plus the change in x. So again, this is not delta times x, it's delta x. So I have, here's the way I like to put it, x and then just a little bit more. And that concept is going to come in handy later when we are, well, finding limits to go somewhere with it other than just for fun. But we're going to be finding limits to go somewhere with it where we're looking at this tiny little space. We're going to be looking at some little graph and we're going to say, well, here's my x value, but this is going to be just a little bit more. And so that's x plus delta x. That's essentially where this is going. We're going to be finding the slope and all fun stuff. It's great. In the meantime, x and delta x are two separate variables. Okay, so don't look at it and say, again, it's not delta times x. Delta x approaches 0. Well, clearly we can't plug a 0 in here, but we have a mess in the numerator to figure out. So let's figure it out. Here goes. We're evaluating the limit as delta x approaches 0. My denominator is delta x. Yay, that one's simplified, but my numerator needs to be simplified a lot. And that numerator being simplified means I'm going to have to multiply x plus delta x by itself and then double that. So we're going to have a mess here. I'm going to deal with that mess later. Let's jump to here. And then minus x minus delta x. If you want to, you can put your parentheses around the whole delta x thing. Sometimes I will as I do this if I find it necessary. And then we're going to have minus 2x squared and then plus x. Am I right? Yeah, that's it. Okay, so here's what just happened. We simplified all of the numerator except the complicated part. So I'm going to go ahead and do the complicated part. I would do it in several steps, but then we'd have to write all this again. So instead, let's go red on this. If I had 2x plus delta x and it was squared, I would really have x plus delta x times x plus delta x. That's what I'd have. So there it is. And I'm going to multiply all that out over there on that side of the board. Let's leave the 2. I like to save it for last. So foiling that out gives me x times x times delta x. And then again, so we would do the outer and then the inner. So x times delta x and then plus delta x, and it is squared. There we go. And we will do one more step. First of all, these are alike. So I have x times delta x and x times delta x. That means I have 2 x delta x's. Well, I have 2 of them, but then I'm going to have to double it. So here we go. 2x squared. 2 times the 2 of these. So this is 2x delta x times 2. So 4x delta x plus 2 delta x squared. If you got lost in all that, don't panic, because often, and this is what we're going to do in this class mostly, instead of using delta x, we're going to use h. So from the very beginning of this problem, for now, if you wanted to simplify it a little bit and say, simplify as in like, I don't understand all this, you could just replace every delta x with an h. And we will do that later. But I also wanted you to see what the delta x represented. It's the change. It's this tiny little minuscule change in x. Okay. That happened here. Again, multiplied it out. 2 of those times 2 gave me the 4. There we go. So back to here. I have 2x squared, 4x delta x, 2 delta x squared. And now we can start simplifying some things. There's a lot that's about to happen. So let's erase some stuff here. Let's grab a green marker and let's cancel some things out. And there's some obvious things that'll cancel out. And one of those things is 2x squared minus 2x squared. Okay, they're gone. Sounds good to me. Negative x plus x. They are gone. Sounds good to me. And then also, for a different reason, I can cancel this delta x with one of those with that one. I can cancel it with one of those and then with that one, and I thought there was a third one, and then divide it out with that as well. I'm going to hold off on that step, otherwise I'm doing too much at once. So far so good, I hope. Let's keep simplifying. I have the limit as delta x approaches 0. And after years of teaching it, I have found this to be the best explanation. Of all the things that are left in the numerator, they all have a greatest common factor of delta x. So let's divide that out. So I would have 4x, 2 delta x minus 1. Okay? And now I can divide something out. And the thing I'm about to divide out, we shall do in red. Done, right? So now I'm left with, can't see through me, can you? The limit as delta x approaches 0. And all I have left is just this. So 4x plus 2 delta x minus 1. And then I'll look at this and say, well, you know, can I plug a 0 in for delta x? Yes. Delta x and x are two separate ideas. So delta x is that. And I would basically have 4x, the x still hangs around, but this is 2 times 0 minus 1. So I'll really just have 4x minus 1. And we're done. Now what did we just find? I'm not telling, but it's amazing. It's actually quite amazing, and you just did something very monumental. Yeah, it's great.